Hello dear students, good morning to one and all. Welcome back to the chemistry class. In the previous session we have discussed about the numericals on concentration units, right? And I have given some extra questions for you. Hope you have gone through that and you have solved. If you have any doubts, please post in the WhatsApp group. In today's session, we'll discuss about a new concept, solubility. Please note the next heading, the concept of solubility. So about this concept we are going to discuss about the definition of solubility, its basic points like definition, factors affecting the solubility, and solubility of two different solutions, solubility of solids in liquids and the solubility of gas in liquids. Solubility of gas in liquids. Solubility of gas in liquids. So these are our concept we are going to discuss. Now, so here, what is meant by the term solubility? What it means? What it represents? Simple definition. Solubility is nothing but, for example, if you add any solute to the solvent, what happens? The added solute molecules which goes into the solvent. So this process is known as dissolution, right? Whereas the reverse process, formation of a solid particle in the solution is called as crystallization, right? So here, when a solute is added to the solvent, its particles are which enter into the solvent. So this process is called as dissolution. And the concentration of this solute, the concentration of solute particles increases in the solution. Concentration of solute particle increases. So here, to what extent a solid is dissolved in a given solvent? The solubility represents the amount of solute which dissolves in a given amount of solvent at a specified temperature, at constant temperature. So here, this term represents its definitions. Very simple definition. The maximum amount of solute which can be dissolved in a specified amount of solvent at constant temperature. So your definition, at constant temperature, or the maximum amount of, its definition is the maximum amount of solute, which can be dissolved, the maximum amount of solute which can be dissolved in a specified amount of water, in a specified amount of particular water, or specified amount of solvent at constant temperature. Temperature must be constant. At constant temperature. At constant temperature or at a specified temperature, fixed temperature. Maximum amount of solute which can be dissolved in a specified amount of solvent. Suppose if you are taking 100 ml of solvent, 100 ml in another beaker. Suppose if you are taking 500 ml of water. So in one case you are taking 100 ml, and in the second case let us say 200 ml, 100 and 200 ml of solvent. So in both the cases, if you want to dissolve some amount of solute, so here amount of solute, some X solute you are adding in beaker A and in beaker B. In which case maximum solute can be dissolved? Yes, 100%, where the solvent is more. If solvent is 100, suppose, so 2 grams or 20 grams, let's say some 20 grams of X is dissolved in 100 ml, then approximately 40 grams of X dissolves in 200 ml of solution, because the volume is not fixed. So at a specified volume, that means a constant volume of solvent if you are taken, then how much amount of solute that can be dissolved in a given amount of solvent, that is called solubility. Solubility represents the maximum solute that can be dissolved. Okay, right, next. What are the factors which affecting on this solubility? So factors affecting the solubility. So you just note down the factors affecting the solubility. So what are the factors affecting? So here first one is nature of solute, nature of solvent, nature of solute and solvent. Nature of solute and solvent. The second factor is temperature. Third one is pressure. Nature of solute and solvent, temperature and pressure. These are the factors which affecting on the term solubility. Now let us explain how these factors which affect the solubility. Okay. So here nature of solute and solvent, because we know that different solutes are present as well as different solvents. The solutes may be a polar or it may be non-polar, polar and non-polar. Similarly solvents also. Some of the solvents, polar solvents, non-polar solvents, polar solutes, non-polar solutes. So this is solubility. A compound is soluble in a particular solvent only if there is a certain interactions between solute and solvent particles, right? The basic rule of solubility is like, dissolve, like. So according to that, like, dissolve, like, dissolve, like, the basic rule of solubility. So what it means, like, dissolve, like? It means that the polar solutes are soluble in polar solvent. Polar solutes are soluble in polar solvents, whereas non-polar solutes, if it is added to the polar solvent, then it is insoluble. Insoluble. This is the basic rule. So that means the nature of solute and solvent, how it affects polar and non-polar. So its polarity. Polar solutes are soluble in polar solvents, whereas non-polar solutes are soluble in non-polar solvents. Non-polar solvents, like dissolves, like polar, polar, non-polar, non-polar. And the second factor is about temperature. As we know that 100%, okay, 100% temperature and solubility. Definitely, solubility varies with temperature, right? Solubility varies with temperature. How it varies? So just here we can say solubility varies with the temperature. It may be increase or it may be decrease. That depends upon the type and nature of solute and solvent. Which type of solutes we are using? What type of solvent we have taken? Depending upon the nature, so solubility may be varies with the temperature. It may be increase or it may be decrease. So in different case, we can study in separate heading. What is the effect of temperature on solubility of solids in liquid, solubility of gas in liquids. So here pressure also affect the solubility. It also varies. Now let us take the particular heading, solubility of solids in liquids. Here you need to mention only 2 points. That is, the first point is the definition, the maximum amount of solute which can be dissolved in a specified amount of solvent at constant temperature, and the second one is the factors affecting on the solubility. That is just mentioned nature of solute and solvent and temperature. Third one is pressure. Next, take the second heading, solubility of solids in liquids. Solubility of solids in liquids. of solids in liquids. So in solubility of, particularly when a solid solute is dissolved in liquids, when solid is dissolved in liquids, what happens? So here, when a solid is dissolved in liquid, the solute, which may be soluble with the liberation of heat or with the absorption of heat. That means this dissolution process maybe it is of two types. One is exothermic and the second one is endothermic reaction. So here this solubility depends upon the same. The first factor is about the nature of solute and solvent. That is like, dissolve like. The second factor, temperature, how it affects on the solubility of solids in liquids. Let's see. Suppose if solute is added, when a solute is added to the solvent, solute plus solvent, this gives rise to the solution. That is, when a solute is dissolved in solvent, which gives rise to solution plus some amount of heat. That means which type of reaction it is? Endothermic or exothermic? Yes, it is exothermic reaction. If the reaction is exothermic reaction. If the reaction is exothermic. Suppose, or else the second case, if the solute, if it dissolves by absorption of some amount of heat, then it gives rise to the solution. That means the solutions may be endothermic. The reactions may be endothermic. In two cases, how the temperature will affect on the solubility of solids in liquid, if the reaction is exothermic or if the reaction is endothermic. Very simple. In class 11 equilibrium topic, you have studied about Le Chatelier principles. Le Chatelier principle, according to the Le Chatelier principle, the effect of temperature in an equilibrium system. So how it affects? The equilibrium is shifted towards in the opposite directions to nullify the effect. Le Chatelier principle. So here, if the reaction is exothermic reaction, then the reactions will be shifted in the opposite directions where some amount of heat will be absorbed. That means towards less temperature. Now, so if temperature is increased, when temperature increases, then solubility of solid in liquid. When temperature increases, solubility of solid in liquid. The solubility of solids in liquid, you can write like this: solubility of solids in liquid increases with increase in temperature if the reaction is endothermic reaction. Is it right? Once check. If the reaction is endothermic reaction, endo means the reaction requires some quantity of heat. So here I am increasing the temperature. When temperature increases, the solute or the reaction which absorbs the heat and the reaction proceeds in the forward direction, that is towards the formation of solution. That means the solute is dissolved. So that means solubility of a solid in liquid increases with increase in temperature only if the reaction is endothermic. This is the first point. The solubility of solid in liquid increases with increase in temperature. The second point is the solubility of solid in liquid decreases with increase in temperature if the reaction is, if the reaction is exothermic reaction. Remember, if an exothermic reaction, if it is considered, exothermic means already in the reaction heat energy is liberated. So in that reaction, if temperature is raised, so according to the Leach-Rayleigh principle, the solute do not dissolve in the solvent. So therefore, its solubility is decreases. Is it clear? Yes. First point, nature of solute and solvent. So in the solubility of solids in liquid, it depends upon the nature of solute and solvent. That is, like dissolves like. Polar solutes are soluble in polar solvent, non-polar solutes are soluble in non-polar solvent. The second factor, temperature. When temperature is increased, solubility of solids in liquid increases if the reaction is endothermic. So it depends upon this condition. If the reaction is endothermic, then solubility increases with increase in temperature. If the reaction is exothermic, then solubility decreases with increase in temperature. So third point is regarding pressure. Third point, pressure. So here, pressure do not have any significant effect on the solubility of solids in liquid, because you know that solids and liquids are less compressible. It is incompressible. So due to its less compressibility, solubility of solids in liquid do not affected by the change in pressure, or it is negligible. So therefore we can say the pressure do not have any effect on the solubility of solids in liquids. So this is the concept of solubility of solids in liquids. Now the next point, that is the solubility of gas in liquid if it is considered. So is it clear? Solubility of solids in liquid. So same points, factors affecting, one is nature, temperature, pressure. Nature is common, that is like dissolves like. In case of temperature, 2 points you need to note. Number one, solubility of this solids in liquid increases with increase in temperature if it is endothermic, or else if it is decreases if the reaction is exothermic. Third point is pressure. Pressure do not have any significant effect on the solubility of solids in liquids. Right. Next, solubility of gas in liquid. This is the important concept. Solubility of gas in liquid. The second point is solubility of gas in liquid. Next heading, solubility of gases in liquid. So in this case, same point. First point is regarding first point, that is nature. Second point, temperature. Third point, pressure. Nature, temperature and pressure. In this case also same point. Nature, like dissolves like. Like dissolves like. That means polar solutes are soluble in polar solute. Here gases. The gases which easily or chemically react with the solvents are highly soluble. For example, let's say ammonia gas, NH3 gas, HCl gas, HCl gas, SO3 gas. Some of the gases which are readily soluble in the water are solvent, whereas some of the gases are said to be insoluble, are less soluble in water. Why? That is because of when these gases, some carbon dioxide, nitrogen gas, less soluble, because when it is passed through the solvent, it forms ammonium hydroxide. That means this gas is chemically reacting with the solvent. So here when it is passed through the water, it also forms HCl solution. HCl solution, that is aqueous solution, is formed when SO3 is dissolved in water or is passed through the water. It forms H2SO4. When carbon dioxide is dissolved in water, it also forms H2CO3 to the lesser extent. So solubility is less, insoluble. Helium gas, insoluble, because it bubble and pass through the water molecules are solvent. So we can say only those gases which chemically react with water are said to be more soluble, whereas other gases are less. So this is the about nature. What about the temperature? Temperature is also an important factor. So look at here. A dissolution of gas is exothermic reaction. When any gas is dissolved in water, it forms a new bond, and we know that formation of a bond is always an exothermic reaction. So therefore we can say dissolution of gas is an exothermic reaction. So solubility of gas in liquid, dissolution of gas is exothermic reaction. That means it liberates heat during the dissolution of gas, that is, and it dissolves with the liberation of heat. So here, since the reaction is exothermic, so when temperature increases, what happens? In the previous case we have studied, when temperature increases, solubility increases only if the reaction is endothermic, but this is exothermic reaction. So therefore, when temperature increases, solubility decreases. When temperature increases, solubility decreases. Third factor is about pressure. Third factor is about pressure. Please note this. Now, the third factor is pressure. So, what is the effect of pressure on the solubility of gas in liquid? This is the important factor, and this factor is explained by the solubility of gas in liquid. It can be explained by quantitatively explained by William Henry, and the quantitative relationship is known as Henry's law. So in the next video sessions we will discuss about the concept of Henry's law, its application, its statement, applications, merits, and some of the numericals will solve in the next video. Okay, thank you.